Today's topic is dilation of figures, and the center of dilation is not at the origin. And we'll use April 29th as our date. Our notes have multiple pages today. So these are the three that you'll need. Yesterday we covered dilations, so what we're doing is enlarging or shrinking our figure down. Yesterday all of the centers were at the origin, but the center of dilation does not have to be at the origin. It can be located anywhere in the coordinate plane. So in this picture here, we've taken our, we'll call it a bow tie, and we've actually shrunk the figure, but B is my center of dilation. Remember, we can always locate our center of dilation if you connect the point of the pre-image with the same point on the image, and you do that for all corresponding points, the center of dilation will just kind of show up. So on this image, it's hard to tell which one was first, but we can tell that these top points are all connected, the bottom points are connected, and the one that's facing to the right. So it doesn't matter if we shrunk or enlarge it, the center of dilation is noted by this point. When we dilate and we're not using the origin, you have to state the point of dilation. So it might be a single point that they're calling point C, and then following that is the scale factor. So this one would have been enlarged using a center of dilation at C. Sometimes instead of using C, they'll tell you where the center of dilation is, like the second example, and then we're dilating it by a scale factor of 1/2, so we're shrinking the figure down. For this example, we're going to draw the dilation of triangle JKL with the center C and a scale factor of 2. So because the scale factor is 2 and it's positive, the enlarged figure will be on the same side as the original figure. Both of these, again, are going to occur on the left side of C. So if you have a straight edge, you're going to want to grab that. I'm going to draw a line, wish I had a ruler, from C through K, and I'm going to extend it. Yours will be really nice because it'll be straight. We're going to mark where we believe K prime is. So this distance here, I'm just going to visually approximate it. With your ruler, you can measure it if you like, but let's just say that K prime is right here. Now we're going to do that with all 3 points. So I'm going to draw a line from C through L, and we're going to continue to draw that. We're going to approximate where L prime is. So visually looking at that distance, I'll go about the same. So maybe here. And now I'll do that with the last point. Let me draw a line from C through J. Oh, this is terrible. And again, I'll approximate where the distance is. We want to be twice as far. So the distance from C to J, and then going that same distance out. So I'm going to approximate it here. This is J prime. And now we can connect the points, and we should have a figure that is twice as big. The orientation is preserved because the scale factor is positive. So we've made a figure twice as large. For the second example, we're going to do the same type of thing. We're going to dilate it, this time by a scale factor of -1/2. So 1/2 means I'm going to shrink it down to half the size, but the negative will place the image on the right side of C. So we want to go in the opposite direction. All right, so let's draw. We're going to draw a line from K through C and continue on. So I'm going to approximate. This would be about half the distance, but I want to go half that distance on the other side. So approximately here, this will be K prime. We're going to draw another line. So from L to C, and I'm going to keep going. So for L prime, half the distance is approximately here. I'm going to do the same over here, L prime. Our last point, we're going to take J, go through C, and continue on. So half the distance is maybe here. I would want to measure that distance. It's maybe here. This will be J prime. And then we'll connect the points. So J prime, K prime, and L prime should be half the size, but it should be on the other side of the center of dilation because of the negative scale factor. If the scale factor isn't provided on the diagram, but you have a pre-image and an image, we can calculate the value of K. We use this with a ratio. We know this from our similarity unit. So what we're going to compare is the image to the pre-image. The image will be your numerator, and the pre-image is your denominator. And by counting the blocks, typically horizontally or vertically, we can come up with a scale factor. So with this image, we're going to determine if it was an enlargement, a reduction, or a congruence transformation, and then we're going to determine the scale factor. So we started with the blue figure, and we created now the green figure. The green figure has prime notation, so I know that this was an enlargement. When you represent the scale, that should also provide an enlargement. If I write the ratio, though, we're going to count the blocks. There are 6 green horizontal blocks, and we're comparing it to 3 blue horizontal blocks. So if I set that up as a ratio, 6 to 3, this tells me the scale factor is 2, so it's twice as big. For this image, this is a congruence transformation. We didn't enlarge it and we didn't shrink it. So if we set up the comparison on this horizontal length, G to H, it's still 3 to 3. It's got a scale factor of 1. And all congruence transformations have a scale factor of 1. In our first example, with the coordinate grid, we're going to plot W, X, Y, Z. We have a quadrilateral. We're also going to plot the center of dilation at -5, 5. So this is my pre-image and my center of dilation. We're going to dilate it by a scale factor of 1/2. It's positive, so we're shrinking it, and it will remain on the same side as the pre-image. It's going to be somewhere in this area. So what I'm going to do is draw a line from the center of dilation to this first point. This first point is actually Z. When you try to establish how close to get, I'm going to look at the slope. How many units do I need to travel up and then left to get to the center of dilation? So we're rising 2 and running 6. To get half that distance, we're going to rise 1 and run to the left 3. So this location here is -2, 4, and that is the location of Z prime. I'm going to do this with each of my points. So the next line that I drew is going to go from the center through point X. Same thing, I'm going to have to rise 2, 3, 4, 5, 6, and run 4. So I'm going to do half. Rise 3, run 2. This right here is the location, -3, 2 of X prime. For our next point, we're going through Y. So from here, I'd have to rise 2, 3, 4, and go over 4. So we're going to do half. Rise 2, run 2, and the location of Y prime is at -3, 3. For W, our last point right here, we would have to rise 4 and run 8. So we're going to rise 2 and 1, 2, 3, 4. So our new location of W prime is at -1, 3. I have the rule, dilate about the center of dilation of -5, 5, a scale factor of 1/2. I'm going to remove the blue lines and plot the new image, And it's as close as I can get, but it is half the size of the original figure. For the next example, if your axes aren't already drawn on there, you should set them up. They need to be offset a little bit. We are dilating by a scale factor of 2, so it's going to be twice as big. But here, this is a negative scale factor, so it's going to flip to the other side of the center of dilation. So let me plot my triangle XYZ. And here's my center of dilation. So because it's a negative scale factor, we're going to be on the right side. So let me start here. This point here at 1, 1 is Y. To get to the center of dilation, I have to travel 1, 2, 3, 4, 5 to the right and up 2. We want to double that, but we're going to keep going over to the right to place it on the correct side. So we're actually moving 10 and then up 4. So this is going to place my new point for Y prime at 16, 7. The next point is going to be here at -2, -1. This is point X. So same thing. We're going to count the path it takes to get to the center of dilation. So we have 2, 4, 6, 8. We have to rise 4. We're going to do that twice. We're going to run 6, rise 4, run 6 more, rise 4. Ultimately, we're going to do the same with Z. The pattern changes each time. 1, 2, 3, 4, 5 to the right, and 5 up. So we're going to go 5 over, 5 up, 5 over, and 5 up. And I think this is the location right here. The ordered pairs are here. There's my rule. Dilate about the center of 6, 3 to scale factor of -2. So it should be twice as big, but the negative scale factor puts it on the other side of the center and it faces the other way. So the orientation is changed as well. Your homework tonight is number 120. There are 5 pages. These are the first 3 and the last 2, in case your packet is still seriously out of order. If you have any questions completing this assignment, make sure you get in touch with me. Otherwise, have a great day.